So number 6 from the 2007 Calc PC FRQ is dealing with Taylor series, and so it pretty much states that f is a function given by f of x equals e to the negative x squared, and problem A tells us to write out the first four non-zero terms and the general term of the Taylor series for f about x equals 0. Now for the AP testing, I would recommend memorizing these following 6 Taylor series representations of these following expressions. Now, these 6 following expressions, or these 6 following Taylor series representations, show up a lot on the A/B test, and e to the x will be the one that we will be utilizing in our problem right now. As you can see, since our function f of x is e to the negative x squared, we're going to treat negative x squared as x and pretty much substitute that into the Taylor series representation of e to the x. Now we get a series of n equals 0 to infinity, negative x squared to the nth power over n factorial. Now this will be our general term of the Taylor series for f about x equals 0, and this is a good way to solve it because oftentimes or sometimes students forget to read the second part of the problem to write the general term of the Taylor series for f, and often just miss those points. So we write that, and then utilizing that, we will find the first four non-zero terms. So first you plug in n equals 0 for the series, and you get negative x squared to the 0th power over 0 factorial, which is 1. And since that's a non-zero number, that will be our starting point, and that will be our first term. And if you plug in n equals 1, n equals 2, n equals 3, n equals 4, we get the following expression. And at the end, don't forget to add the general term to make it cleaner. And then if you simplify that, we will get 1 minus x squared plus x to the 4th over 2 minus x to the 6th over 6. And then a simplified general term of negative 1 to the nth power times x to the 2n over n factorial. One thing you have to make sure is to start where n equals inside the sigma notation. So over here, sigma equals n equals 0, so we start with n equals 0. But for example, if you have a function ln of 1 minus x, the sigma actually starts at n equals 1, so 1 is the first value that you have to plug in. Part B tells us to use our answer from part A to find as limit of x goes to 0, 1 minus x squared minus f of x over x to the 4th power. So part B deliberately tells us to substitute in for f of x from part A, so we're just going to do that. And so we're just going to write out 1 minus x squared minus the first four terms that we got in part A, and then plus dot dot dot, just so we know that it's continuing, obviously. And all of that over x to the 4th, and that looks very hideous at first sight. However, after we simplify that out and multiply that out, 1 minus x squared cancels out, and we get left with negative x to the 4th over 2 plus x to the 6th over 6, and dot 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 over x to the 4th. And if you simplify that further, we get as limit of x approaches 0, we get negative half plus a bunch of terms that are going to cancel out to be 0. So the answer is negative half. And two things I want to say about this problem is that, first of all, the problem looks very hideous at the start, but I would just recommend just keep going through it, even though it looks hideous. Just solve it out first, because if you try to use L'Hopital's rule or some other method, it will take a much longer time, in my opinion, and plus, you can not get the right answer. And second thing is that I would just recommend just skipping over this problem if you're in a time crunch. This is number 6, and this is part B, and part B, as you can obviously see, does not relate to part C and D. So if you are in a time crunch, I would just recommend skipping over this problem because it's only 1 point out of 9. So part C basically tells us to figure out the first four non-zero terms of integral of f of x, and use the first two terms of our answer to estimate integral of 0 to a half to e to the negative t squared dt. Obviously, you can just find the first four terms by doing it the long way and then writing it all out, but what I would recommend is just taking the integral of the first four terms of part A, since we already did part A. Whatever your method is, we get x minus x cubed over 3 plus x to the 5th over 10 minus x to the 7th over 42. Now, the second part of part C tells us to use the first two terms to estimate integral of 0 to half of f of t. Now, how we do that is just we take the first two terms of our first four non-zero terms and just substitute in half for x, and from that we get 11 over 24. Now, part D tells us to explain why the estimate found in part C differs from the actual value of what we try to find, integral of 0 to half e to the negative t squared dt by less than 1 over 200. So to find that, we have to know that the series is alternating. And because the series is alternating, this means that we have to use the third term because we used the first two terms for our estimate. And looking at a third term, it's x to the fifth over 10, and we have to substitute in 1/2 for x, and that means we get 1 over 320, which is less than 1 over 200. Now, we can do this because this is an alternating series. If this wasn't an alternating series, we would have to use the integral method to see if the error is less than a certain value. And because 1 over 320 is less than 1 over 200 and the series is alternating, this proves why the estimate found in part C differs from the actual value by less than 1 over 200. Thanks for watching, and additional problems will be in the description down below.